Hello, my name is Professor Nicholas Embleton, and I'm a consultant neonatologist in Newcastle, which is in the north of England. And I'm going to be talking today about the importance of human breast milk for preterm infants. And I want to focus particularly on the nutritional aspects, but also the microbial aspects and the importance of brain development and the stem cells that you can get from human breast milk. Now, neonatal care is really complex. All of you working in neonatal intensive care will recognise the complexity of the equipment, the technical challenges, and many of the problems faced by these babies. And every day on the ward round, we will discuss numerous aspects of neonatal care, such as the need for phototherapy for jaundice, the right forms of vascular access, the fluid requirements in a baby, how much oxygen we should be giving them, how we should treat their blood pressure and determine whether it is too low or too high, what we do about infection and CRP markers, and also a whole range of ventilatory aspects. So we can all agree that neonatal care is really complicated. However, the focus appears to be on cardiorespiratory management, and generally, especially over the first few hours and days, there's a lack of focus on nutrition. And I want to here emphasize the importance of involving parents in neonatal care right from the very first hour. Now, this lack of focus on nutrition and the fact that in the first few days malnutrition is largely invisible means that poor growth is actually very common on neonatal units. And I often wonder if we had a machine that alarms when nutrition was suboptimal, if we had some form of machine that could measure the protein and energy intakes and provide us guidance in the same way that a cardiorespiratory monitor provides us feedback on the system. Now, one of the key points I'd like to emphasize is that nutrition is more than nutrients. Often when you talk about neonatal nutrition, people focus on nutrients. Obviously, all of the macronutrients and all of the micronutrients, the fats, the proteins, the vitamins, and the trace elements. But there's another element here, which are the functional components. These could be bionutrients or immunonutrients, and these include human milk oligosaccharides, growth factors, enzymes, but also cells that are in breast milk, and I'm going to talk about that at the end of the talk today. We've become increasingly aware of the importance of the microbial aspects of feeding in early life, particularly for premature babies. These may be breast milk microbes that are acquired in the breast milk itself or promoted by specific components present in breast milk. But microbes are also acquired from the environment and may be deliberately administered in the form of supplemental probiotics. And the fourth element of nutrition that I want you to think about are what I call the technical and the socio-behavioral aspects. And these may be questions about whether you should bolus feed or continuous feed, but also the role of kangaroo mother care, skin to skin, direct breastfeeding, and all the sensory aspects involved in feeding. Now, breast milk is more than food. We think about all these different components, as I say, the nutrients, the functional nutrients, the microbes, and the technical aspects. What we know is that greater macronutrients, particularly over the first few weeks, lead to better long-term brain outcomes. We also know that the amount of mother's own milk you receive is directly correlated with better long-term brain outcomes in these babies, and there may be multiple potential mechanisms here. Microbes may also play a role in brain benefits via the gut-brain axis. We know that babies who receive human milk have a much lower incidence of necrotizing enterocolitis, and this means that there are fewer babies exposed to the cytokine storm of necrotizing enterocolitis. And this cytokine storm, we know, can result in white matter damage. So preventing NEC also improves brain outcomes. Then, as I say, we want to think about breast milk being more than food. All of the sensory aspects, the importance of kangaroo mother care, and the maternal psychosocial benefits from being able to provide breast milk for their babies. Microbes are key to infant development. And I like this phrase that birth seeds and breast milk feeds. So the mode of delivery, whether you're a vaginal delivery or a C-section delivery, impacts on the type of gut microbes you have at birth. But then this is promoted by the type of milk feeding, and we know that breast milk feeding in particular promotes the growth of certain healthy bacteria. So microbes are acquired from the mother and from breast milk, and these determine ongoing gut health. We know that early on, what we call pioneer species, so particularly anaerobes such as bifidobacteria and Bacteroidetes, these create a low oxygen environment and sustain a low oxygen environment. Then after that, breastfeeding with the components such as human milk oligosaccharides, secretory IgA and microbes lead to successive waves of colonization. And this is one of the key impacts and reasons why breast milk results in better long-term outcomes and better gut health for preterm babies. Now, this rather complex diagram explains some of the relationships here. What we see in the upper left is a mother feeding her baby, and the grey arrow depicts the transfer of microbes into the baby's gut lumen. The baby also acquires microbes from the areola and skin surrounding the mother's breast. The baby will have microbes growing in the mouth, and these are also swallowed. And then there are a range of interactions specific to human milk that take place within the gut. We know that human lactoferrin interacts directly with lysozyme, but human lactoferrin also promotes the growth of certain healthy bacteria such as bifidobacteria. There are many mechanisms through which secretory IgA in breast milk impact on microbes and probably reduce the risk of necrotizing enterocolitis. Human milk oligosaccharides, which are unique to breast milk, impact on the growth of bifidobacteria. But there's also evidence that human milk oligosaccharides interact directly with T lymphocyte cells in the lamina propria. We also know that the type of microbes you have present in the gut affect the production of key chemicals, for example, short-chain fatty acids. And the production of short-chain fatty acids impact on tight junctions in the gut. And the microbes in the gut also interact with gut-associated lymphoid tissue, and this in turn produces cytokines and IgA. And finally, the microbes that are present in the baby's mouth may somehow backwash into the mother's breast, creating a kind of cycle of microbes that are beneficial for the baby's health. Breast milk is more than food. Breast milk exerts its benefits via microbial aspects, but also the metabolites that it produces. And when I first started in neonatal medicine more than 25 years ago, this was how I thought about breast milk. I thought of breast milk going into this long tube, which was the gastrointestinal tract, and that out of this tube we suck out the fluid and nutrients, and then we produce waste product at the end. That was what I thought breast milk feeding was all about. But what we've come to learn over the last 20 years is that the complexity of gut metabolism is incredible when we consider human milk, that there are a whole range of metabolites, hormones and microbes that are directly impacted by breast milk. And breast milk also transmits cells from the mother to the baby. So we can think of breast milk as a developmentally regulated, individualized nutritional and signaling pathway from the mother to the infant. And this emphasizes that nutrition is more than nutrients and that breast milk is more than food. So what are the human milk components that lead to better outcomes? Well, there are literally hundreds of different components in breast milk that may be responsible for some of these health benefits. Compared to formula, we know that breast milk has a different proportion of certain amino acids and proteins and secretory IgA, which isn't present in formula milk. Human lactoferrin present in human milk is different from lactoferrin from cow. Although there are oligosaccharides in formula milk, these are not the unique short-chain oligosaccharides that are called human milk oligosaccharides present in human milk. There are also different proportions of fatty acids, and all of these components interact with microbes in the gut. And then depending on the specific pattern of microbes, the baby may produce a different amount of short-chain fatty acids such as butyrate. Microbes also produce amino acids and peptides which may be of nutritional benefit. They produce bile acids, choline, and also a range of vitamins, particularly vitamin B and vitamin K. And they may also produce a whole range of anti or pro-inflammatory molecules. Furthermore, there are likely to be signaling molecules which act via the gut-brain axis. We have one brain for life, and breast milk evolved to meet the needs of the very large brain in humans. What we see in most primates is that the rapid period of growth takes place prior to term, so that most primates are born relatively mature. In contrast, Humans are born during the rapid phase of the brain growth acceleration. Between 24 weeks gestation and 2 years of age, humans acquire about 85 to 90% of their final adult volume. And the majority of this rapid growth happens in the third trimester and the first few months after term. So human nutrition is focused on the needs for a very large brain. Although this rhinoceros has a very large head, it actually has a very small brain. And in comparison, in humans, the brain fills the entire cranial cavity. Here's another way of looking at it. Along the x-axis, I show you body weight on a logarithmic scale, and up the y-axis, brain weight. And you can see that whilst most mammals plot out somewhat on that average line, in humans, the brain is about 10 or 20 times as big as most other mammals. And so everything about placental physiology and human milk composition is designed to help promote brain growth in humans. So what's the evidence for the specific benefits of human milk? What we know from a series of MRI studies over the last few years is that human milk improves brain growth and white matter connectivity. In this recent study of 62 premature infants born less than 32 weeks, they had an MRI scan performed at term. And this included babies who were human milk fed and babies who were formula milk fed. And they were able then to compare those two groups. And what they showed was that in breast milk, the babies had higher total brain volumes, larger amygdalus and hippocampus, and larger cerebellum. And on the right-hand side of the picture, I show you white matter connectivity using diffusion tensor imaging. And this shows that white matter organization in babies receiving human milk is superior to that on formula milk. Here's another study where they looked at 47 preterm infants born less than 33 weeks. And these babies also had an MRI scan performed at term. And what they did was to look at the number of days where breast milk provided the entire milk input. So they called this exclusive breast milk, and they looked at those babies that had exclusive breast milk for at least 75% of their days on the neonatal unit. And what they could see was better connectivity, particularly in the corpus callosum and the corticospinal tracts, even after you've adjusted for gestation and lung disease. And in the lower half of that diagram on the left, you can see that babies who have exclusive breast milk for more than 90% days have even better connectivity. So strong evidence that breast milk exposure improves structural connectivity. In this study, they looked at 180 infants. They looked at the days where breast milk represented at least 50% of the daily milk intake over the first 4 weeks. And they adjusted the analysis for all the usual factors. And what they showed was that 7 years later, when daily breast milk represented more than 50% of the intake, these babies had better performance IQ, working memory, and motor function. So that for every extra day where breast milk was more than 50% of the intake, there was a 0.5 IQ advantage for every single day. And finally, I want to emphasize that cells in breast milk are unique. In this picture here, you can see on the left-hand side the different types of cells that might be present in breast milk. And these fall into two groups, either breast milk-derived cells such as lactocytes and myoepithelial cells, but also some stem cells. But breast milk also includes blood-derived cells. These are immune cells, hematopoietic stem cells, but also probiotics. And these enter the infant gut when the baby is receiving human milk, and these are then absorbed, and they traffic themselves to a range of organs. And there really are a huge amount of cells in breast milk. On the left-hand side here, you can see the number of cells that they've counted for each week of lactation. And roughly there are between somewhere like 10,000 and 10 million cells per mil of breast milk. So if you're breastfeeding, you probably take in between 5 million and 10 billion cells a day. And on the right-hand side, you can see some work that's been conducted looking at whether these might be stem cells. And they do this by looking for specific cell surface markers that identify these as pluripotent stem cells. And what they show is that up to 30% of the cells in breast milk may actually be stem cells. So it's increasing data to suggest that these stem cells engraft and integrate themselves into the baby's organs, particularly the liver, lung, and perhaps the brain. But these stem cells have a very limited lifespan. They will die after 4 hours at room temperature in the milk. So we need fresh mother's own milk, not frozen or pasteurized. And in a pilot trial of just 200 babies, they compared standard treatment to those babies where they ensured that the baby got at least one fresh breast milk feed per day. And in this study, they showed that the babies receiving fresh breast milk had a lower rate of necrotizing enterocolitis, retinopathy of prematurity, sepsis, and lung disease. And so finally, I want to emphasize that providing good nutrition is a team effort. We need lactation consultants, pharmacists, dietitians, and physicians. But really at the center of this is the infant and the family. So in summary, neonatal intensive care is complex. We need to have a better focus on nutrition. Nutrition is more than just nutrients, and breast milk is more than food. Microbes are key to many of the benefits in human milk, and these are microbes present in breast milk, but also supported by components in breast milk. And human milk improves grain outcome, and this has been shown using MRI. There are stem cells in fresh mother's own milk, which may be very crucial to development in our babies. And we need really good teamwork with parents and babies, and this emphasizes the importance of family integrated care. And I'd like to thank you very much for your attention.